Now, what we're going to look at is logarithmic function and its graph. Basically, today I'm going to show you how to do transformation and think about how you could transform the logarithmic graph and how you relate that to your exponential function, and also think about, if you are given a graph, how to find the equation and stuff like that. Alright? So, let's think about what is a one-to-one function. Many want to, you should recall what a one-to-one function is.
Yes.
Alright? If you've got a one-to-one function, f, and that's actually an inverse function, f of to the power of minus 1, or inverse function. Alright? So that other function, when there's an inverse, if it is not one-to-one, it's many-to-one, it's actually inverse relation rather than a function. Alright? Then we'll talk a little bit about thinking about the reflective property of logarithms, critical features, apply the function transformation, and things like determining the equation and stuff like that. Alright? So can you now first use your class back to plot those two graphs? Y equals to x plus 3 over 2 and y equals to 2x minus 3. You need your class back. If you haven't got a class back, come and grab one from me. Who hasn't got one? Everyone got one? Plot graph. You need to plot.
Yep.
Yeah, but
What's the black
Henry, where's your class back? No, it's not okay. You have to learn how to use the class back. It doesn't matter. Doesn't matter. You need to really plot it because we're going to do a few things. You go, class back.
Arcing the inverse.
Come and get one.
Yeah.
No, you got to use your own. No sharing. Class back, no sharing. I've got 4 class backs here. You need to use how to learn. You really need to use how to learn how to use your class back very efficiently. You must do that. I don't want anyone to share class back. So,
Wow.
if you do it properly,
That's
you should have a linear line of this, right? 1 equals x plus 3 over 2 and the other one is 2x minus 3. Have a look at this.
They are
Now,
about the line y.
Here, this line and this line. How could you relate this line to this line?
Flipped over y equals x.
A
Yep.
reflection.
So, from here to here, the y has been transformed to the x here and the x has been transformed to the y here. Correct? Or if you look at this point here, this point x is minus 3, this point y is minus 3.
Yeah.
Right?
Yep.
So this point y is 0, that point x is 0.
Mm-hmm.
This point here, that's 1.5.
Yeah.
So y is 1.5, x is 1.5. But here x is 0, y is 0. So what basically I've done is interchange the x and y between this function and that function. Alright? So the x coordinate of y equals to x minus 3 is now the y coordinate of that. When I go from here to here, or vice versa. It's the same thing as well. Y of this is now the x coordinate of that. So that is, they are interchanged. Alright? Can you notice something else?
Yes.
What is the line of symmetry?
Y equals x.
Oh, not symmetry, sorry, reflection.
Y equals x.
Y equals x. So, if you draw a line, you can see that this is actually reflected about y equals x. Here, we'll go to there. This bit comes to here. Agree?
Agreed.
Yeah? Alright. Now, let's quickly talk about inverse function. So, consider a function of f of x mapping to y. It maps an element of x from the domain x to an element of y in the range y. So the inverse function of f is just a function that reverses the mapping y to x. That's all. Alright? Now, given that y is mapping back to x, especially each coordinate pair is being mapped to y, xy is being mapped to yx, this creates a reflection about the y equals to x. That line. Okay? for any given one-to-one function f, there exists the inverse function. All right? Now, remember, if it is not one-to-one function, if it's many-to-one function, there is no inverse function. There's inverse relation, but no inverse function. Just recall when we did this equation, y equals to x squared. When we do an inverse, is x squared equals to y. And there is actually, this is a relation, this is not a function. All right?
Isn't y squared is equal to x?
Okay, so to find an inverse function, swap the x and y,
squared
and
is
then
x, that's-
we solve for the new y.
equals x
See
squared.
what I do? Now, let's use this as an example.
Sorry, sir.
Doesn't matter. So what I need to do in this case is, I am going to swap the x and y. I will show you the procedure. You don't necessarily have to know how to do it, but I need to show you. All right? I'm swapping the x and y. See that now? I'm swapping the x and y. From there, what I do is rearrange this so that it's in terms of y. All right? Multiply both sides by 2, and what we get is, this is the inverse function, y equals to 2x minus 3. So when you plot it on the graph, it's reflected about y equals to x. This is just using that as an example. Now, I'm going to relate this to your exponential function. How do we obtain the inverse of the exponential function?
Log A both sides.
Before that, if I use the previous way of doing it, if I swap y and x, what do I do? I can swap y and x and then take the log of both sides. Alright? So swap first and then take the log rather than take the log first. Happy with that?
Yep.
So now y equals to log a of x, and therefore y equals to log a of x is the inverse of y equals to a to the power of x. Alright? So this is the exponential function. The inverse of an exponential function is y equals to log ax. Happy for me to move on?
Yep.
Okay. Now, let's consider the graph of y equals to 10 to the power of x. Can you determine the equation of the inverse function of that? Y equals to f. Y equals to f minus 1x. Can you do that? What would that be? What would the inverse function be? So if you're going to go step by step,
Carrot.
swap it over x equals to 10 to the power of y. So log 10 of x equals to y. So y equals to log 10x. Alright? You don't have to write the 10 if you don't need to. Can you now use your class method to plot the graph of y equals 10 to the power of x? You need to identify the coordinates and its inverse function. So identify the coordinates of any intercepts and equation of any asymptote. And then state the domain and range of y, the inverse function of x, which is y equals to log 10 of x. Alright? Let's do that first. Use your class pad to plot the graph. I need you to be able to use your class pad. So I'm going to, the next slide, I will be explaining B, C, and D.
Yeah.
Alright? So, if you plot your class, use your class pad, y equals 10 to the power of x. And y equals log x.
Yep. Lose the inverse.
Here you go. Use your class pad, please. Do some work. Do the plotting of this.
Bro, why was...
Alright? Now, it should look something like this. Here, sort of stop here. It should actually go all the way down.
Yeah.
It should be, there should be asymptote. Alright?
Why doesn't it go all the way down?
It's just because of the class pad. If you use some other
Decimals.
program decimals, it will go all the way.
Yeah.
Yeah, it's just the quirkiness of this, the way it was programmed. That's all. So now you can see that y equals to 10 to the power of x, where's the asymptote?
Y is 0.
Yep, which is x-axis. What about asymptote for this? Log 10x.
X equals 0.
X equals to 0, which is y-axis.
It switches.
Alright, so now, let's think about what is important. Here, you've got a y-intercept. There, you don't have a y-intercept. Correct? Because the asymptote is y-axis. Therefore, it will never cross y-axis. So there's no y-intercept for y equals log x. Whereas this one, there is no x-intercept. Alright? So the key point is 1 and 10. So if you go up 1, it's all the way up 10. And of course, if you don't want to plot, the other key point is here, -1 and 1 over 10. Alright? Whereas this is a flip over, important point is the x-intercept. And of course, if you want to plot, you have another point. This is a horizontal asymptote of y equals to 0. This is a vertical asymptote of x equals to 0. Alright? So you can see that if I draw y equals to x, is that reflected?
Yes.
Reflected, and the axis of reflection is y equals to x.
Yeah.
So, a quick summary. So for the general exponential function y equals to ax, the y-intercept is always 0, 1. The key point is 1a, which is 1, when x equals to 1, and the horizontal asymptote is y equals to 0, always. Whereas for the general logarithmic function, the x-intercept is always 1, 0. See the difference? Alright? 1 is the y-intercept, 1 is the x-intercept. Key point is a1. So, when y equals to 1, this is a. Y equals 1, this is telling me that this is this line here. The blue line is a is 3, so is log 3x. This one is, I think, I can't remember, it's somewhere here. Alright? 9, 10. Okay? So see the difference where this is important. This key point here is important because you will be able to identify what A is. Alright, eventually you'll be asked to identify what A is. I'll show you an example a little bit later. Alright, now, describing it. Alright, so here, you can see that as x approaches infinity, y approaches infinity as well. Whereas when x approaches negative infinity, y approaches 0. Forgot the 0 here. Alright? The next graph, which is y equals log x, x approaches infinity, y approaches infinity. Whereas x approaches 0, y approaches negative infinity. So you must be able to describe it. Now, consider y to the power of a x and y equals log ax. What we have is, in this situation where a is greater than 1, this is actually a exponential increase. Alright? And it's an increasing function. Whereas this one is a decreasing function, exponential decay.
Yeah.
Correct? Yeah? Growth and decay. Yeah? Looking at the rate. Growth and decay. Here, if I take an inverse of y equals to a to the power of x, y equals log ax, this is an increasing function as well. Increasing function, increasing function. Here, reflected, this is decreasing function, this is also a decreasing function.
Yes.
This is how you identify it. When you need to identify the graph, you need to remember these 2 points. Either greater than 1 or between 0 and 1. It cannot be 0, it cannot be 1. Alright? Now, so, just as a summary, I am now going to avoid using A because I'm going to use A as a transformation. Alright? So I'm just going to use base R now. So the inverse function of an exponential function base R is the logarithmic function of base R. Alright? So y equals to r to the power of x. The inverse is y equals to log base R to the x. Happy with that? This is just a summary. Now, recall your year 11 methods.
BCAD.
Yes, your transformation BCAD. So B and C, when you actually transform function of x to that function, a times f of b x plus c plus or minus d, we use BCAD where b and c actually affects the x coordinates, whereas a and d affects the y coordinates. Right?
Yep.
So b, you go to factor it out. B is dilation parallel to the x-axis by a factor of 1 over b. Reflected about the y-axis if b is less than 0. There will be a log negative x. I'll show you what later. Alright? C is translation in direction of x-axis. That way or that way. Alright? B and C only affect the x coordinate. Yeah?
Which one is first in the order of transformations?
BCAD. Always follow BCAD.
So when you describe
So
it-
dilation, translation, dilation, translation.
Oh, okay.
Alright, dilation, translation, possible reflection, dilation, translation, possible reflection.
Yeah.
Follow that order. You'll be right. Dilation, translation, reflection. Oh, I mean reflection and translation you can swap, but I would do translation, then reflect.
Yeah.
A lot easier in my opinion. Again, dilation, translation, reflect.
Okay.
Yep, alright? So A and D only affects the y coordinate. Now, can you use your class back to plot this? 3 of this. Y equals log 3, x, log 2x, and log 0.5x. You will be able to see 3 graphs. And so you should. Now, important thing is look at the key point and how the key point has dilated. Alright? So this one is dilation. Alright? So if you've done it, it's something like this. Now, what I want all of you to look at is from the blue line. Alright? The blue line, the important point, let me try to enlarge that. Let's have a look at this. Alright? You know that B only affects the x coordinate. So from here to here, or actually let's go to the green line first. From this bit to this bit, what is the increase?
1. Well,
1
double.
and double, the number is double.
Yeah.
Right? So therefore you can see that the red line is 2x. What you do is
Half.
you go for 1 over b of that. Alright? And whereas, 1 over b of that, 1 of 0.5, whereas this one is half. Alright? So the observation, generalizing, y equals log of r, y equals log of rx, transforming to y equals log of rbx, is dilate parallel to the x-axis by a factor of 1 over b, and reflected about the y-axis if b is less than 0. Alright? Vertical asymptote is still 0, and x-intercept is now 1 over b, 0. Alright? That is important. You can recognize it. Now the thing is, you should be able to write the domain. What is the domain? The domain is x is greater than 0. Yeah? Whereas the range of y is just an element of the real number. Happy with that? So now you should be able to think about what the x-intercept is, how you could work out the x-intercept. And always state the x-intercept is as coordinate. Alright? Now the next bit, this is the reflection. Here, when I'm just using b as 1. Alright, I've got log x and log of r minus x. Why do we have minus now? Because this is minus number. Minus 1 times minus 1 became 1. Minus 2 times minus 1 is 2. So therefore, in this situation, you've got the log of minus x.
Yeah.
All right, minus minus because negative negative. So you can see that you can reflect about the y-axis when r is greater than 1. All right, whereas it's between, you are reflecting that way as well. All right, slightly different, the two different graphs. Happy with that? You would have negative x because you've got a negative number. Negative times negative 1 is 1. Negative times negative 2 is 2. All right, so therefore you have that. All right, so can you use your class pad to plot this, please? This time is C. I am showing you all BCAD, but in fact in the SCASA syllabus, we need to be mindful of the sideways translation and up and down translation. I'm not showing you everything.
It's almost like it translates to the
So,
left and
plus
right.
2 minus 2.
Oh.
Again,
Who would have guessed?
you've got something like this now. All right, like I say, this is the quirkiness of class pad. It should always go all the way down. All right. Now, how do you? Let's again concentrate on this point. All right. So if it is minus 2, it moves to the positive direction of x. Correct? Move to the right. And if it is plus, it moves to the negative direction of x. So it's going to the left. Agree? So now, what you need to see is where has the asymptote moved. So the asymptote has moved from that to there. All right? Y equals to 0. In this situation, where you've got x plus 2, all right? The asymptote of that has moved across to x equals to minus 2. This one, the asymptote has moved across to x equals to 2. Correct? Now, then you can work out the intercept. So the intercept, we started off with 1. All right? You need to remember, you've got to use 1 plus or minus c. It depends whether that's plus or minus. All right? Yeah? Now, again, you need to note the change in domain. The next thing I want you to be conscious of. In this sort of translation, you may get y-intercept. See?
Yeah.
The red line now has y-intercept, whereas the blue and the green line does not have y-intercept. So, tricky question is sometimes they will ask you to translate and ask you to identify the intercepts. There will be situation in this case where you will have the y-intercept. There is now a y-intercept for this one. X plus 2 because you're moving back, so you've got a y-intercept. What happened at y-intercept? What equals to 0? What equals to 0 at y-intercept?
X.
X equals to 0. So, this time if I use log 3x, so if you've got a calculator, of course you get the decimal places, but if not, it's just log 3 of 2. Alright? If you're asked to plot or sketch, that's just log 3 of 2, that's all. You don't actually have to give the decimal places. Happy with that?
Happy.
Now, let's move on, let's try this. This time is dilation parallel to the y-axis, up or down. So you got 2 and 0.5. You start off with the base, log 3 of x. If you've done it properly, it should be something like this. And again, this time, I would, instead of using 1, because that doesn't work, I will use this. Okay? I won't use x equals to 1, I will use x equals to a, or x equals to 3, to look at the multiplication. Alright? So the factor now is, you can see that this is going down by 0.5, this is multiplying by 2. Use the key point. Always use the key point to look at the dilation factor. All right, you know that this is affected by a factor of 2, affected by a factor of 0.5. All right, so therefore, this time, let's generalize it again. Dilation is now parallel to the y-axis by a factor of a. Now again, you can reflect about the x-axis if a is less than 0. All right. Vertical asymptote is still x equals to 0, and the x-intercept is still 1, 0. And again, the domain for x is greater than 0. X has to be greater than 0. Not greater than or equals to is greater than 0. All right. So remember, domain, I better write it down. Domain x is such that x is the element of R, x is greater than 0, not greater than or equals to. Remember that. That is important. Alright, so you can see that I've done, this is, the blue is the log of R. Log of x. I use log 3 in this case. So log of x, and then if you got negative, the y value changes reflected about the x-axis. See, the asymptote is still the same. Whereas this time, it's a decreasing function, the decay, and then you flip it over. It became something like this, the negative. All right, just for you to know, you need to know that. I'll move on now to the next one. Can you use a class pad? This is probably the most straightforward.
Just goes up or down.
Plus or plus 2 and minus 2. So you should get something like this.
Did it move up and down?
It went up and down.
So it's moving up and down. Again, use the key point. Look at the movement up and look at the movement down. Alright? I use this. Plus 2 is gone up by 2. Minus 2 is gone down by 2. Alright? Again, this time, there is no change in the asymptote. It's still y equals to x. Now, the intercept is this. R to the power of plus or minus d. Minus or plus d. Alright? So here, you can see that when this is moved down by 2, the x-intercept is now r to the power of 2, which is 9. Alright? Whereas this is r to the power of minus 2. Or 3 to the power of minus 2. Alright? So you need to know how to work out the x-intercept in this case. You know the vertical asymptote is still the same, and you know that there's no change in domain. The domain is still greater than 0, and the range is still real numbers. So make sure that you know how to identify the range and domain.
Still imaginary numbers. Is that logs in imaginary numbers?
Would the domain not stay the same?
Alright, let's move on.
So,
Yeah.
would the domain not stay the same?
Sorry?
Would the domain not stay the same?
Yeah, the domain stay the same, the range stay the same as well.
Oh,
Greater than 0. Yes, the domain and range stay the same for this one. Alright? Now, so, just generalizing everything. If I've got y equals log base r of x to y equals to a log r, bx plus or minus c plus or minus d, you should recall b and c is dilation parallel to the b and a is dilation. B is parallel to the x-axis and by a factor of 1 over b. Reflect about the y-axis if b is 0, less than 0. So, dilate and then reflect. Alright, then translate in direction of the x-axis, left or right, or positive or negative. A is dilation parallel to the y-axis, up and down by a factor of A, reflected about the x-axis if A is less than 0, and translate in the direction of the y-axis. So following this, I should say, do the dilation and reflection and then translation. It doesn't matter whether you translate or reflect first, as long as they're consistent. Alright, as long as they're consistent, that's important. This is all from what you learned last year, basically the same. Now, example 2. Here, can you write the new equation? Talking about translation only. So 3 units up is, right is, so the base really does not affect the equation, but you need to know how to do this. So that is just log of x plus 3. Now this one to the right, that way, so you know that it has to be inside the bracket x minus 5. Alright? So up is outside the bracket, up and down. Left or right is inside the bracket. Let's try those two. I'll show you my answer in a few minutes.
Minutes.
You better get 100% the next test, alright, Henry?
Yes,
You go, come on. You should be able to do this. So, left, x plus 2, and then 1 unit down, take away 1. Right, x minus 4, 6 units up, plus 6. Alright, example 3. Can you state the location of the vertical asymptote and the coordinates of any axis intersects in the following functions? Now here, some of it you might have to identify the y-intercept. Some of it you may not have to. Alright, you need to think about which one will have y-intercept, which one does not have y-intercept. I mean, the first one is pretty obvious. Is there a y-intercept? Is there a y-intercept?
No.
No, because it's log 4 of x moving up and down. So there's no y-intercept. So identify the x equals to 0. Ooh, what did I say? X equals to 0. Oops. Alright, x equals to 0. Alright. Now, then the intercept is 4, 0. Alright? X intercept. Okay? Because x intercept is y equals to 1. So log 4 of x equals to 1. Therefore, the x intercept is 4. Alright? Try those, please. So plus 16, where does it move to? Left or right?
Left.
Left. So is there a y-intercept?
Yeah.
Very good. So now what is the asymptote? X equals to minus 16. So this time you need to work out the x-intercept. You know straight away because it's moved across. It's just whatever 16. Take away 1. That's it. All right. And you can work out what the y-intercept. Try the next two, please. I know I don't see all of you on Monday, So tomorrow might be a long lesson as
Normally
well.
the x-intercept is at
So that
0.
we can finish things on
So
time.
trace it back 16.
Alright?
It's negative 15.
So
Negative 16.
here, where is it moving to, left or right?
Right.
Right? So is there a y-intercept?
No.
No. Very good. So asymptote is x equals to 4. So you can see that the asymptote is just x equals to negative value of this, negative value of that. Alright? And you can work out the x-intercept is when this equals to 0, which means that is log 3 x minus 4 equals to minus 2. So therefore 3 to the power of minus 2 is x minus 4. So therefore x is 37 over 9. Alright, so that's it. Always give your intercept in coordinate form. Alright, last but not the least, try the last example, please. Y equals log of 5, x plus 25 minus 3. Is there a y-intercept in this case?
Yes.
Yes, because it's moving to the left.
Yeah.
So therefore there's a y-intercept. Right?
2, 0.
So if you move to the right, there will not be y-intercept. But you move to the left, there will be
Fine.
y-intercept. So be very careful. Just look at what the transformation is.
There's a y-intercept for the third one as well, isn't there?
Sorry?
There's y-intercept for the third one as well.
No, that's not because we are moving to the right.
Oh, yeah,
Moving to the right, so there's no y-intercept. And straight away you can write out the asymptote. Now x-intercept is when that equals to, straight away, I wrote that down, that equals to 3. And therefore 5 to the power of 3 is x plus 25. And you should be able to work out x is 100. So the x-intercept is 100, 0. So I'll let you work out the y-intercept. Y-intercept is when x equals to 0. So when x equals to 0, log 5 of 25 is 2. And therefore, you have y equals minus 1 and 0 minus 1. Alright? So all you need to remember is whether x is 0 or y is 0. So this one, you need to know that because it's moved to the left, therefore you've got a y-intercept. Whereas this one moving to the right, originally the asymptote is x equals to 0 because it's moving to the right. It does not cross the x equals to 0. So it will always be no y-intercept.
So can I please go to the toilet?
1 minute.
Yeah, okay. It's alright.
All right. Now, this is the one that I want to show you
So you want to-
how to sketch. Can you sketch this?
0.25.
Yes.
How?
Draw it.
Now, you're given a log of 0.25. All right, the base is 0.25. So what is the important thing to look at? What is 0.25?
1 over 4.
1 over 4.
1 over 4. So what are the numbers that you want to look at? 1 over 4, 0, 4, 16, and so on and so forth, or 64, right? So think about that. Now, the first thing I'll do is asymptote. I'll look at that, I'll draw the asymptote already, one thing. So I know that the graph will not go over that, all right? And you know it's 0.25, so you know that the shape is this way, all right? Because a is less than 1. So you know that it's decreasing function. That's important. Two things. So you know the general shape, you know the asymptote. You know 0.25 is 1/4, so you look at things like 0, 4, or 16, etc. To make life easy, you'll get 2 points. So the first point that I'm going to look at is, think about this, log of 1/4 of 1 equals to 0. If that equals to 0, I know y equals to -1. Correct? So if that's equal to 0, what would x be? What is log of 1/4? So you know that x plus 3 equals 1, so therefore x equals to minus 2. Right? X plus 3. Always remember, log of any base of 1 is 0. Right? So therefore you know that has to be, you want that to be 0 so that you can work out y. Yeah? So therefore you can work out y is minus 1. You know that's minus 1. I just did that step again, that's all. You don't really need to do it. So you know 1 point, minus 2, minus 1, which means you've got 1 point already. Alright? And then the next point, what you need to look at is when that equals to log of 1/4 of 4 equals to minus 1. Alright? You want that to be 4. Yeah? Agree? So once you know that's to be 4, therefore you know that that's minus 1, and you can work out x plus 3 equals to 4, x equals to 1. So you got 1 and minus 2, you can work out y, and you got 2 points. And you know that the asymptote is there, you just have to draw the line. I didn't even identify the y-intercept or x-intercept. You can if you want to. Alright? If you identify y-intercept, is when y equals to 0. X-intercept is when x equals to 0, if you want to do that. Alright? I haven't done that. I'm just sketching it very briefly. I will confirm whether you need to find the x or y-intercept. But to find the x, y-intercept is pretty straightforward. If y equals to 0, that equals to 1. That's all. Yep.
Do you have any give 2 points?
Sorry?
For graphing, do you have any?
Yeah, just 2 points and the asymptotes. And I think, strictly speaking, you should work out the x and y coordinate. But in this case, I'm just showing you how to use the 2 points. Alright? So I'll probably put a note down here. X and y-intercept.
Y-intercept seems hard to find, right?
Y-intercept, yeah, it is a little bit harder to find.
Yeah.
But you just, it's a whole number. You just say it's exact value. You can just write it down. That's all.
Oh yeah. Okay.
Yeah, just, you're not expected to use your whatever.
Yeah.
All right. I think. Okay. Now here, you've got. Ignore that for a minute. Now the graph show 4 different lines. Y equals to log a of x. Y equals to log a of x minus b. Y equals to log a of x plus c. All right. Notice the c is not included in the bracket, and y equals log a of dx. All right. So now, can you determine the value a, b, c, and d? All right.
Yes.
First thing you need to look at is how do you determine a? A is important because A will help you. Once you find your A will help you find all the others. All right. So first one to look at, I will identify the line, the graph with 1, 0.
Yeah.
Anything with 1, 0, you know that you can find. It must be y equals log a of x. So log 2 of 1 equals to 1. So therefore, I draw that. So log 2 of 1 equals to 1. Therefore, a equals to 2. All right? A equals to 2. All right? So the next one, this one indicates that it's a horizontal translation, which is moving across. All right? So I identify this line, this yellow line here. All right? I identify that line, and I know that this has been translated across. So translating across, you know that it's across by 3 units to the left, right? Since it's negative, that has to be -3. Therefore, it's plus 3. Trick.
So it says positive integers.
Yeah, they are all positive.
I should have used that word, positive integers.
There you go. Now it's
They are.
gone.
I don't know
Getting
why
there.
I mean positive integers.
Yeah.
I know. I I was half asleep when I was doing this last night. Get rid of the positive integers. My fault. Thank you. Alright, there should be all integers. Then you look at the green line. So you know the green line. Again, you look at points. Alright? So you know this is translated out by 1 unit.
Yep.
So therefore C equals to 1. Then you look at the orange line. This time, look at the
Wait, D equals.
what the factor is. 1 to 4. So therefore D equals to 4. So you got to do step by step. Important thing is to look at what A is first. Once you located A and determine what A is, the others a little bit more straightforward. Alright? Yeah? So you don't even have to write out the equation, you just need to find A, B, C, D, and E.
Wait,
A,
sir.
B, C, and E. That's
Sir.
all. Alright?
Sir.
Yeah.
For D,
Yep. 1.
you know the point 24, right?
Yes.
24. So if you write log base 2, D times 2, and you equal that to 4,
Yeah.
you get 2 to the power of 4 equals 2D.
2 to the power of 4 equals to 2.
Which is 16 divided by 2, which is
Yeah.
Oh, hang on. It is 1. It's affecting the factor is affecting the y coordinate.
no, because it has to have moved across. Because the asymptote is completely different.
It's not. We don't have to
has
think
to
about the asymptote at all.
So
in
it's
this
not
case.
down.
Oh, yeah.
Yeah, got
Just
it?
move the
Yeah.
powers,
So that's affecting the y only. All right. Last but not the least.
Yeah.
So sometimes you need to use log equation, solving logarithm log
-2.
equation graphically. All right. I'll show you how to do it. I'll show you how to do it. Whatever already. I'll show you how to do it algebraically. So all you need to do is able to read from the graph.
Yeah.
So for example, you know log 2
no, that's not 1 to
of x equals to 2.3. So read this from here, 1 and 2, about 2.3. Alright? So if I draw it, a straight line, it's something like this. So therefore, you can say that x is approximately 5. I know the printout that I gave you is not that clear, but this is how you do it. Second one, again read from the graph.
Has to be.
-1, where's -1? -1 is here. Alright? So, again, estimate. From the graph is estimate 0.5. See that?
It's only moved across.
And then, the next one, x. Here, this bit,
Same thing as here.
you must be able to rearrange it. So if you rearrange it, you know the log 2x equals to 3.2. Then read. Read the graph, and you get approximately 10. And finally, this one, x plus 3, approximately 13. And therefore, because x plus 3, 3.8 is 13, approximately 13 is x. This is actual using calculator. Now, how do I use the calculator? There are a few ways of doing it. Let's use x minus 2, x minus 2 to the power of 3.2 equals to 0 as a guide. Alright? So one way of using it is you plot.
What we?
Oh, let me get that out first. I need to get out of that. Go to class back. Alright? Where's my class back?
3.
Alright. So, class back.
It's just a program.
Alright, if you go to class back, you should be able to go to first. We are going to use x.
Just a program.
X equals to x minus 2 equals to 3.2. One of the things you can do is use solve, keyboard solve. Solve x minus
No, it just like searches for
2 to the power of 3.2
If I wanted to get a definition, I just go on the exam and copy the definition.
equals to 0. Alright, you can work out what your x is. Pretty straightforward. Alright? Yeah?
Yeah.
All happy with that?
Yep.
So there are a few other tricks that you can do, like using your graph. So if you use your graph,
I don't scan it, I put it into my thing.
let me get my solution up.
I just put it straight.
Couple of things that you need to know. Alright, one other way of doing is plot the graph of log. Alright, plot the graph of log 2 of x and then plot x equals to 2.3 and then you find the intersection. So if I go to menu and under graph and table, I'm going to edit clear all first. Alright? Clear all. The first thing is you type in log 2 of x and the other one is y equals to 2.3 or 3.2, whatever. Alright? So if you draw the graph and you can find the intersection point. Alright, you can find the intersection point. That's one way of doing it. Alright, the other way is actually to plot y equals to log x without the second one. Just plot that and use your analysis g solve x count or y count. That's all. Alright, so I'm going to stop here. And there should be enough exercises for all of you to do. And like I say, this was a long lesson. Thank you for paying attention.